everyone, I'm Dan with Science Matters in America from Portland. Today we're going to be separating water into hydrogen and oxygen using electrolysis. Come along. So, what do we need for today's experiment? We need a D battery, that's one of those square ones with the leads on top together. A clear cup, preferably plastic. 2 glass tubes, or if you don't have these glass tubes, you can use a small glass cup or 2 small glass cups. Some baking soda, and a fire source. I like the matches, but because we're using fire, we need to take all the cautions so we don't get hurt. That's safety glasses and our fire extinguisher. Alright, let's get started. So, what we'll need first is to take our clear plastic cup, our baking soda, and put in a small amount of baking soda, just enough to slightly coat the bottom. You don't really need too much. Then we'll add some water. I'm just using tap water here, but distilled water from a water bottle works significantly better. We want to fill it to above where the battery lies. I'm going to take our glass tubing here, add a little bit of water into these. Try to do this over the sink so you don't make a mess like I did. Take your battery, place it into your cup. And immediately you'll see bubbles start forming at the positive and negative lead. Now I got my glass tube filled with water. I'm going to try to use a little bit of sleight of hand and tip this onto that lead without losing a bunch of water. Fantastic. I still have a lot of water in here. I'll do my second tube. Great. So now we have 2 tubes on top of these leads. Each of them has water and they're filling up with bubbles. Now we wait. Now remember, do not try this experiment without adult supervision. Welcome back. So, as you might be able to tell, this battery, the 2 leads on the battery have been forming bubbles. It's actually displaced the water that we had in these tubes. So these tubes were filled up with water roughly to here. Now this left tube, or I guess on your screen to the right, is way down. This one's about to here. So there's a gas that's been filling up these tubes. What is this gas? Let's try to find out. So a good way to identify what a gas is seeing how it reacts to certain things, let's say a flame. Look at that flame. So that was the positive lead of our battery. Let's see what happens when we introduce flame to the negative lead of our battery. Whoa! Woo! Y'all hear that? Quite a good pop. Look at that charred region right there. So, what happened? Well, on our battery we have a positive side and a negative side. The baking soda water allows a current to flow between these 2 leads. Now, this electricity induces the electrolysis of the water, so the separation of the hydrogen and the oxygen. Electricity rips these molecules apart, forming 2 gases, hydrogen and oxygen. And those were the bubbles we were seeing as they became gases moving themselves from the water. And when we introduced the flame, oxygen, the one that was attracted to the positive lead, because oxygen is a negative gas, opposites attract, that's the one that burned bright. It's a property of oxygen gas. The other gas we had was hydrogen. That's the one that went pop, because hydrogen is a combustible gas. It's what the Hindenburg was made out of and why it exploded. Remember, do not try this without adult supervision. Now, for everyone at home who may not have some of this glass tubing, you can also use a 3-ounce beverage cup. And as you might see, there might be some calcification or other ions that are attracted to the battery, and they might change the composition of your water, but as long as you're seeing bubbles, the experiment's still good. Now everyone, thanks for watching, and remember, like our Facebook page and subscribe to this YouTube channel. Science matters in America.